The next topic is ammeter and voltmeter. So we're going to talk about ammeter. Ammeter is a device which is useful to measure the current. So to measure current, we use ammeter. So the symbol for ammeter is a circle with A in it. Okay, don't get confused with this. This is a current source. Okay, this is a current source. Ammeter, we always use A inside it. The ammeter, the internal resistance of ammeter is 0. Okay, and it must connect in series to measure the current. Because if you look at any circuit, let me connect an ammeter here. So here is the resistance, which is a 10 ohm, which is connected to a 10 volt source. Okay, so before connecting the ammeter, what is the current passing through it? I must be V over R, 10 over 10. It must be 1 ampere. What happens if I have internal resistance in the ammeter, say like a 1 ohm? Now the current value is going to change, right? So in reality, the ammeter, theoretically, ammeter value must be equal to 0. Practically, it might have very small value, small resistance. Okay, so ammeter, the internal resistance of an ammeter is 0 and it must connect because the current always flow inside of the wire. Okay, so to measure how much current is there inside of the wire, we need to connect it in series. Now, if we connect an ammeter in parallel, it may damage the circuit or it might give you false reading. Say for example, here, if I connect an ammeter in parallel. If I connect an ammeter in parallel, now what is going on here? The internal resistance is 0 ohms. So 0 parallel with 10 ohm, that will be 0 ohm. Now what is the current? I equal to 10 over 0, infinite ampere. So huge amount of current is going to pass through this. And whenever the current comes here, at this point, it sees 0 ohms. 0 ohms there, it sees 10 ohms there. So the current, there won't be any current passing through this. All the current is going to pass through this to reach the negative. So it will damage the ammeter. Some other case, say for example, I have something like this: 5 ohm, 5 ohm, and then 10 volt. Now if I connect my ammeter in parallel, okay, now what happens? This has 0 ohm parallel with 5. 0 parallel with 5 is 0 ohm. Now what is the current passing through this? I equal to, so this resistance, this whole resistance is going to be 0. So you will end up with only 5 ohms. 10 divided by 5, which is 2 amperes. Before connecting ammeter, how much current was passing through this? Before connecting ammeter, it's supposed to flow 1 ampere because 5 plus 5, 10 ohms, and the current must be 10 divided by 10, 1 ampere. Now what happened? Because of connecting your ammeter in the wrong way, the current passing through the circuit is changed. So sometimes if you connect your ammeter in parallel, sometimes it may damage the circuit, sometimes it may give you wrong reading. Now the next topic is voltmeter. Voltmeter is useful to measure the voltage. Okay, nowadays we don't see the individual voltmeter, ammeter. Nowadays you see multimeter, where you can measure resistance, capacitance, voltage, current, and so many other things. Okay, so we call that as multimeter. But here I'm going to talk about voltmeter. So you need to turn the knob on the multimeter to the voltage side to measure the voltage. Anyway, it is useful to measure the voltage, and this is a symbol for voltage source. Don't get confused with the source. So here this is a voltage source, here this is a voltmeter. Okay, this is voltmeter, this is V source, voltage source. Now voltage, remember, voltage is always between 2 points. Okay, so you must connect voltmeter between 2 points. Now internal resistance of a voltmeter is infinite, so it must connect in parallel. If we connect voltmeter in series, it will it will break the circuit. I mean, that means it will open the circuit. I think open is a better word. It will open the circuit because of the infinite resistance, but it will not damage the circuit. Okay, so similar way, I'm going to do the same thing. 10 ohms, okay, and 10 volts. So here the current must be, I must be 1 ampere and V must be 10 volt. V, I'm talking about voltage between or voltage across this 10 ohms. Now if I connect a voltmeter here, my voltmeter is supposed to give you a reading of 10 volts. Instead of that, say for example, if I connect that in series, okay, if I connect that in series, now this one has infinite resistance. So what is the R total? R total equal to infinite plus 10, which is infinite. I equal to V over infinite, so 0 amperes. So it will not give you I mean, it will not let the current pass through the circuit. But at the same time, this voltmeter is going to read 10 volts because the positive is connected to the 10 volts. Now negative is connected to the, I mean, since there is no current passing through this, 0 ampere, so voltage drop across this is 0, still it will read 10 volt. In the same way, if you have something like this, okay, 5 ohm and then 10 ohm, and I'm going to connect voltmeter like this and then 10 ohm. Okay, in this case you can clearly see this is going to act like a, before this, I mean before connecting the voltmeter, say for example I don't have this, if I don't have voltmeter, then these two are in parallel, 10 parallel with 10, which is 5 plus 5, 10 ohms. The current supposed to be 1 ampere. I supposed to be 1 ampere, and here it is 0.5 ampere, here it is 0.5 ampere. Now to measure the voltage, you can connect voltmeter in parallel between any 2 points. So if I want to find the voltage across this 10 ohm resistor, connect voltmeter between these two, it will give you 10 times 0.5, which is 5 volt. Now instead of that, you connected voltmeter in series. Now what happens to this resistance? This will act like a open circuit because this voltmeter has infinite resistance. Now 5 ohms, 10 ohms act like they're connected in series. Now what happens to your I? 10 divided by 15, now 2 by 3. Your current value is changed. It's supposed to be 1 ampere. Now since you connect your voltmeter in wrong way, the current passing through the circuit is 2 over 3 amperes. So never connect voltmeter in series, never connect ammeter in parallel. That's about ammeter and voltmeter. Now I'm going to talk about two more laws, which is KVL and KCL. So the next topic I'm going to talk about Kirchhoff's voltage law, KVL. So KVL tells us that in any closed circuit, a circuit is nothing but elements connected together, 2 or more elements connected together with a closed loop. So here I have 3 elements. One is voltage source, resistor 1 and resistor 2. These 3 elements are connected together and I have a closed loop. Closed loop is nothing but start walking from one point, reach the same point without touching any element more than once. Okay, that's called closed path. So here there will be voltage drop across R1, that is called V1. Voltage drop across R2, we call that as V2. So according to Kirchhoff's law, in any closed circuit, voltage drops must be equal to voltage gain. So start walking from one point. If you are entering positive terminal, take that as a voltage drop. If you are entering negative terminal, take that as a voltage gain. Now before that, I labeled this plus or minus. How come? Because resistor never produce voltage. Resistor always produce, it consumes current, or it consumes the energy basically, or it takes the electrical energy, gives you either light energy or heat energy. So start walking, and If you see a resistor, when you are entering, label that as a positive. Okay, start walking in this direction, that's positive, negative. Here also I'm entering positive, negative. For the battery, this is already given. Whenever you see the small line, that's negative. Whenever you see large line, that's positive. Now, according to Kirchhoff's voltage law, voltage drop equal to voltage gain. Okay, now, so KVL is nothing but voltage drop equal to voltage gain. Now, how do you define voltage drop? If you're entering positive terminal, take that as a voltage drop. Voltage gain, if you're entering negative terminal, take that as a voltage gain. So start walking from one point. If you're entering positive, take that as a drop. So I'm entering positive, so I'm walking in this direction. I'm entering positive terminal, so V1 is drop, plus V2 is also drop, and V is gain. This is the Kirchhoff's voltage law. So in any closed circuit, voltage drops equal to voltage gain. So in any closed circuit, in engineering, electrical engineering circuit, simply we write it as CKT. Okay, CIRCUIT, circuit equal to CKT. That's a short form. Okay, so this is Kirchhoff's voltage law. The next one is Kirchhoff's current law, KCL. Kirchhoff's current law. Kirchhoff is a person name. Okay, current law. This is also called KCL, Kirchhoff's current law. At any junction or node, that junction could be a node, also called essential node, doesn't matter. So here is the junction. There are a few wires coming in, going out. Okay, so say for example, I1 entering, I2 entering, I3 leaving, I4 leaving, I5 entering. So current coming in, current in equal to current out, going out. Current coming in equal to current going out. So here I can see I1, I2, I5, those three currents are coming in. I3 and I4, those currents are going out. So according to Kirchhoff's law, at any junction, currents in must be equals to currents out. So I1 plus I2 plus I5 equal to I3 plus I4. This is KCL. So with this, I'll stop this video. If possible, in the next video, I will solve a couple of examples based on KVL and KCL. Thank you.